Find the first three non-zero terms of Maclaurin's expansion for f of x is equal to sine x. Okay, suppose we write sine of x is equal to a polynomial, a plus bx plus cx squared plus dx cubed plus ex to the fourth plus f x to the five. And what we're going to do is find the values of a, b, c, d, e, and f. Okay, going to look at this GeoGebra applet, and I'll put that in the notes of the video. So if we start where this is equal to 0, f of 0, okay, that will give me this line, which is only going to be really true at that particular point, okay? So we could probably improve the approximation, but my a in my expansion will be f of 0, which is sine of 0, which is actually 0. So actually that's a 0 term. So, okay, if we do 1, okay, then the next term is f of 0 plus f dash of 0 of x. If you differentiate sine, you get cos. So sine of 0 is 0, but cos of 0 is 1, so we get 1x, okay? And that's a better approximation than the previous one. You can see it's pretty good near to 0. If we take the next term, okay, we notice that this has not changed. Now, the reason why it's not changed is because if we take the second derivative of sine, so differentiate 1, you get cos, differentiate cos again, you get minus sine. Okay, so this becomes minus sine 0 over 2 the x squared, and sine 0 is 0, so again we just ended up with x, so that's a 0 term, so that won't count. Okay, if we do the third, okay, we can see we get a better curve here, an even better approximation here. Okay, we get p of the third polynomial approximation could be f of 0 plus f dash of 0 plus f double dash of 0 over 2 factorial f, the third derivative, over 3 factorial x cubed. So if we differentiate minus sine like we got here for the previous one, we get minus cos. But cos of 0 is actually 1. So we're going to get 1x from here, and then 1/6 of x cubed from here. And we can see here we have the a better approximation. When we do the next one, the derivative of minus cos is sine. And obviously when we do the sine of 0 divided by 24 here, the fourth term here, it becomes 0. So we've got a 0 term. So we've ended up with the same curve. If we do the next one, we can see that's even better approximation. You can see that. Okay, and so if you differentiate sine, you get cos, so you get this term here. Cos of 0 is 1, so we need to add on 1 over 120x to the power of 5 to our other two terms. And this is the first three non-zero terms of the expansion for sine x using Maclaurin's series. Maclaurin's series is got by doing this. If we continue that, we'll probably... Okay, I didn't write out the expansions, but you can see the approximation gets better and better. Okay, remember when we're doing this, of course, that the angle must be measured in radians because we are differentiating. Okay, this GeoGebra app I will put in the notes of the video. I hope you've understood, and I thank you very much for watching.